Let us see our next chapter, some applications of trigonometry. In this chapter, we will discuss about height of the buildings and height of the towers by using perpendicular distance from the base. Now, before going to find this one, let us see the introduction. The eyesight parallel to the eye is called normal eyesight. Suppose a flight is moving, then our line of eyesight will be above the normal eyesight. Suppose for example, let us see, here a flight is moving, then our eyesight will be changed to above to the normal eyesight, that is, which is called angle of elevation. Next, suppose we stand on the first floor of the building. Now some persons are moving on the ground floor. Now our eyesight will be just down to the normal eyesight, which is called as angle of depression. That means in this chapter we deeply studied with about the angle of elevation and the angle of depression. Now let us see once again, the angle of elevation is the angle above to the normal eyesight and the angle of depression is just below to the normal eyesight. Let us see the next example. A tower stands vertically on the ground from a point on the ground which is 15 meters away from the foot of the tower. The angle of elevation of top of the tower is found to be 60 degrees. Find the height of the tower. Let us draw the diagram first. A tower stands vertically on the ground. Let AB be the height of the tower and which is 15 meters away from the foot of the tower. See, that means this tower is 15 meters away from a particular point. The angle of elevation of top of the tower is found to be 60 degrees. Just to we discuss that the angle of elevation means the eyesight will be above to the normal eyesight. That is, the top of the tower is B, the angle is 60 degrees. And the foot of the tower is 15 centimeters, 15 meters away from the foot of the tower. Find the height of the tower. That means we have to find out the height of the tower AB. Now let AB be the height of the tower. Let AB be the height of the tower and AC be the distance from foot of the tower. That is, AC is equal to 15 centimeters, 15 meters. Next, from point C, the angle of elevation to the top of the tower is 60 degrees. That is, angle of elevation is 60 degrees. Here in this condition we have to learn the two things. That is, one, if you know any of the two sides, that is either the base or the altitude, use the tan or the cot function, or if you know the hypotenuse, use sine or the cos function according to the situation. That is, from triangle ABC. From triangle ABC, tan theta is equal to opposite side by adjacent side. Now opposite side to 60 is AB and adjacent side is AC. That is tan 60 degrees is equal to AB is the height of the tower, which we have to find, by AC equal to 15 meters. That is, we know the value of the tan 60 is equals to root 3 is equal to AB by 15. That is, therefore AB is equal to 15 root 3 meters. Therefore, height of the tower AB is equal to 15 root 3 meters. Now let us come to the second example. An electrician has to repair an electric pole of height 5 meters. Now let us draw the diagram first. That is, AB is the electric pole which height is 5 meters. He needs to reach to a point 1.3 centimeters below the top of the pole. That means below the top of the pole you have to mark another point. That means suppose AB the height of the pole is, the electrician has got a repair at point C which is just below 1.3 meters. That is 1.3 meters this is. Now what should be the length of the ladder which inclined an angle of 60 degrees? That is, let D be the position of the ladder which makes an angle 90 degrees with the base. Now the ladder is supported at the point C and which is also making an angle of 60 degrees. Now how far from the foot of the pole? How far from the foot of the pole? Foot of the pole is A. That is, from here to how far the ladder must be placed? It is a question for us. Now let us see. Let AB be the height of the pole. Let AB be the height of the pole and AB is equal to 5 meters. And let C be the point of observation. Let C be the point of observation. Point of observation means where the repair occurs. Now we have to find out the value of the AC. AC is equals to AB minus BC. That is equal to AC is equal to the value of AB is 5 meters minus BC is 1.3 meters. That is, AC is equal to 5.0 1.3, that is 7, 1 borrowed, 3 minus 1, sorry 4 minus 1, that is 3, that is 3.7 meters is the height of the part of the pole. Height of the pole is 5 meters. Now AC be the height of the part of the pole, that is 3.7 meters. Now let us consider and then the angle of elevation is 60 degrees. That is, from triangle ACD, tan theta is equal to opposite side AC by adjacent side AD, that is tan theta. Tan 60 degrees is equal to AC value is 3.7 by AD value we have to find. Now AD is the distance from foot of the pole to where the ladder was placed. That is tan 60 nothing but root 3 is equal to 3.7 by AD. Now here in the question, root 3 is equal to 1.73. That is root 3 value we have to find out now. That is AD is equal to 3.7 by root 3. That is AD equals to 3.7 by 1.7. That means approximately point after I will consider as one digit only. Now AD is equal to 37 by 17. That is AD is equal to 17 table 37, 17 twos 34, that is 3.0 one time 17, that is 13 is the remainder, again place 0. Now 17 8s are 136, that is approximately 7 times, that is 2.17 meters in terms of brackets approximately. That is AD is equal to 2.17. What is the AD? The distance from foot of the tower to where the ladder was placed. Next, after this I have to find out what is the length of the ladder. Again, from triangle ACD, that is sine 60 degrees is equal to opposite side by hypotenuse, standard formula. Now opposite is AC by hypotenuse is CD. Sine 60 degrees is root 3 by 2 equal to AC value 3.7 by hypotenuse CD we have to find. That is root 3 into CD is equal to 3.7 into 2. That is CD is equal to 2 sevens 14.7.4 by root 3. That is CD is equal to 7.4 by root 3 approximate value which is corrected to one decimal place is 1.7. That is CD is equal to point after the numerator one decimal place, in the point after also in the denominator also point after one decimal place, therefore the decimals are balanced. Now let us see the next calculation. 17 table 74. Now that is 17 5s 85. Okay, next 17 4s 68, that is a 4 times. Now the remainder is 6.0. Now 17 3s are 51, that is 4.3 meters approximate. Therefore length of ladder CD length of ladder is 4.3 meters. Let us follow the next example. From a point on the ground, the angle of elevation of 10 meters tall building is 30 degrees. A flag is hoisted at the top of the building. The angle of elevation of top of the flagstaff is 45 degrees. Find the length of the flagstaff and distance from the building, distance of the building from the point P. Now from a point on the ground, the angle of elevation of 10 meters tall building, let AB be the height of the building, that is 10 meters. Let AB be the height of the building. Let AB be the height of the building and AB is equal to 10 meters. A flagstaff hoisted at the top of the building. Now let us consider AB is the top, AB is the height of the building, and on the top of the building a flag is hoisted, that is BC is the top of the flagstaff, that is let BC be the flag height and C be the top of the flagstaff. Now after that, the angle of 10 meters tall building is 30 degrees. A flagstaff is hoisted at the top of the building. The angle of elevation of the top of the flagstaff is 45 degrees. Now let us see the diagram. Let AB be the height of the building, which is 10 meters in height, and BC be the length of the flag and C be the top of the flagstaff. Now from a point P on the ground, which is perpendicular to the base, now the angle of from a point on the ground, the angle of elevation of 10 meters tall building is 30 degrees, that is B is the top of the building, it is 30 degrees. Now from the same point, the angle of elevation of top of the flagstaff is 45 degrees. Now find the length of the flagstaff. That means you have to find, let BC be the flag height, that is length of the flag. After that, one more thing what you have to find, distance of the building from the point P, that is you have to find AP also. Now the angle of elevations, from point P are 30 degrees and 45 degrees. Now let us consider from triangle A, first consider the small triangle, from triangle APB, that is APB, take out A, B, P, that is from triangle APB, which makes an angle 30 degrees and height is 10 meters. Now here we know the opposite side, tan theta is equal to opposite by adjacent, that is tan 30 degrees is equal to opposite is AB by adjacent side is AP. Now tan 30 degrees is equal to 1 by root 3 is equal to, the value of AB from the diagram is 10 by AP, that is AP is equal to cross multiplication 10 root 3. Now in the question it is given that root 3 is equal to 1.73. Now AP is equal to 10 into 1.73, that is AP is equal to, by using this 0, one digit will come inside, that is 1 into 17.3, that is AP is equal to 17.3, which is meters, and it is a approximate value. What is the AP? That is distance from foot of the building, to point of observation. AP is equal to 17.3 meters. Now distance from foot of the tower to foot of the building to the point of observation, just now we find out. Next we have to find out the length of the flagstaff. From triangle ACP, from triangle ACP, let us see from triangle ACP. Right angle is at A, C, there is a P. In between the point B is there, which is 10 meters in height, and the angle of elevation is 45 degrees, that is tan theta is equal to opposite side AC by adjacent side AP, that is tan 45 degrees is equal to AC can be break down into two parts, that is AB plus BC by AP. Now tan 45 which is equals to 1 is equal to AB value is 10 plus BC by AP value, just we find out that one 17.3. Now 17.3 is equal to 10 plus BC. Now we have to find out the value of BC. Now BC is equal to we have to find out the value of the BC. BC is equal to 10 minus 17.3. Now let us find out the value of BC. BC is equal to 17.3 plus 10 moves other side, that is a minus 10. BC is equal to 7.3 meters, which is in approximate. Therefore length of flagstaff is 7.3 meters.